Welcome to Stats 1430 final review. We'll firstly look at this problem about the number of people going to a local bank. From this problem, we know that the number of people who go to a local bank in a random week varies with mean 145.6 and a standard deviation 24.5. Because we know that the number of people can only take on whole numbers, so this distribution cannot be a normal distribution. Now we look at the first part. Let x bar be the mean number of people going to this bank in a random week during the year, and we know that there are 52 weeks in a year in total. And we want to know what is the approximate distribution of x bar according to the central limit theorem. Remember that the central limit theorem tells us if x has any distribution, not necessarily normal, with mean mu and a finite standard deviation sigma. So if x is any distribution with mean mu and standard deviation sigma, which is finite, and then when n is large, if n is large, the sampling distribution of the sample mean x bar is approximately normally distributed with mean mu and standard deviation sigma over square root of n. So basically this is the statement of the central limit theorem. Okay, now because x bar is the mean number of the people going to this bank in a random week, and from the given condition, we know that x bar is approximately normally distributed with mean mu equal to 145.6 and standard deviation of sigma over root n, that is 24.5 over 50 square root of 52, and this is about 3.398. Okay, so basically x bar is normally distributed with mean mu equal to 145.6 and a standard deviation of 3.398. Alright, this is the first part. For the second part, where we want to know based on the distribution you find above, which is the normal distribution, what is the probability that the mean number of people going to this bank in a random week during a year is equal to 100? That means we want to find the probability of x bar equal to 100. But remember that x bar has normal distribution, and the normal distribution is a continuous random variable. Then, by your previous knowledge of a continuous random variable, the probability of observing a single value is always 0. That means the probability of the x bar equal to 100 is equal to 0. And this is the second part of this problem. Finally, for the third part, we want to know, based on the distribution you find in the first part, what is the probability that the mean number of people going to this bank in a random week during a year is less than 150. So basically here, we are looking for the probability of x bar less than 150. Okay? So X bar, based on the first part, we know that it has a normal distribution with mean 145.6 and a standard deviation of 3.398. And to find its probability, we have to convert it into the standard normal distribution. That is a normal distribution with mean 0 and a standard deviation of 1. By doing that, we can subtract both sides by the mean, which is 145.6 in this problem, divided by the standard deviation, that is 24.5 divided by square root of n, that is 52. And do the same thing for the right hand side. 150 minus 145.6 over 24.5 divided by root 52. And then you can see that this part is a standard normal distribution. I'm going to use Z, capital Z, to represent the standard normal distribution, less than, if we do the calculation of the right hand side, we know it is equal to 1.29506. And by looking at the normal table, or by using software or using your calculator, we can see this has probability of 0.90235. Okay, this will be the final result.